Section 1 is one-step equations. So, solving equations is the inverse of order of operations. It is the undoing of an equation so that an unknown variable can be solved. This value is what makes the specific equation balanced, all right? So every equation has to be balanced. It means the left-hand side has to equal the right-hand side. Otherwise, the equal sign would not be there, all right? Therefore, when you are solving equations, the same, what you do to one side, you have to do to the other, right? It's just like when we find common denominators. What you multiply your denominator with, what you do to the denominator, you have to do to the numerator. It's the same with here. What you do to one side, you have to do to the other side. Is true for all equations. An equal sign states that the left-hand side is equal to the right-hand side. To keep this equilibrium, when you add, subtract, multiply, or divide one side, you must do the same to the other side. Adding and subtracting is the last operation performed in the steps of order of operation, so it is where you will start in solving equations. And then multiplying and multiplication and division is the second thing, all right? So what we're doing here is we're actually undoing things, all right? So undoing means that we are going to do the opposite operation that is in the question. So if I look at the very first examples, all right, and I know that you can know what X is right off the bat just by looking at these. That's why they're one-step questions, all right? But one-step questions are the basics. What I'm expecting is the work that goes with it. So please make sure that you're doing the work that goes with this. So when I have X minus 5 or X subtract 5 is equal to 4, right? I want to undo that question so X is by itself. Everything is about isolating X, all right? So if I'm subtracting something, right? If I have a negative 5, I want you to think of it as negative 5. If I have a negative 5 things, how do I get it back to 0? So every single time we want to eliminate, because think of a balance. You're thinking of a balance with these. So if I was, somebody go in cupboard 12 and grab my algae tiles. Okay, are they up on the top there somewhere? Maybe cupboard 11.
I can see them.
No, cupboard 11. They're in a black and white container. No, I think they're in a black and white. They might be in the next one. Is that the one? Yeah, any of the X's and the numbers. Are they around there somewhere? All right. Zoom. So I'm going to model this question right here. All right? Because we all can look at it and know exactly what X is. But the process of it, I want you to start thinking of it a little bit differently rather than just going and looking at a question to figure out what the answer is. I want you to undo the question. So we have to understand what the question actually consists of. All right? So here is my X. All right? I have minus 5. So that side has this. There's my minus 5. All right? And then I have my equal sign. And then on this right-hand side, I have a 4. I slide this underneath so I can write.
Oh my God, you messed it up.
I did mess it up.
Oh my God.
It's okay.
That was the first thing I ever seen.
Let's fix this. There we go. Oh. All right. So let me put that there. So there we go. Flip those. So we got negative 5, negative 5. And I want you to think of the, there we go. So there's my thing. And I'm going to actually draw an equal sign here.
Oh, really?
So that we have it there. All right. Now I've got it. My videos are so professional. Look at that. Okay. You always agree with me.
No.
All right. So I have X. So we have to think of it as a balanced scale, right? If I want X by itself, right, I have to undo these negative 5s, all right? So think about when we did adding and subtracting integers. How would I get rid of a 5 so that they don't exist anymore, a negative 5? I had to put
plus
5. So I have an X minus 5 here equaling a 4, all right? So if I add 5 to this side, all right? I add 5 to this side. What happens to these? They cancel out. So I can eliminate them. And I have the x by itself. But what I do now, is my equation still balanced? I did something to the left-hand side, but I didn't do it to the right-hand side. I must do the right-hand side. What did I do to this left-hand side? I added 5. So I must go and add
X equals minus
this 5 to the other side.
That took like 5 minutes.
I know, they're going to get faster. I just did it with pictures. Do you see how what I do to one side, I have to do to the other side? So this right here now, x is equal to 9.
Can't you just add 5 and 4 together?
No. So you must undo the operation. So this is where I'm talking about the process has to be. I must see this. So in a question, this is what I'm expecting to see. All right? So in here, I need x to be by itself. I have a minus 5. How do I get rid of it? I add 5 to this side. That's going to, but what I do to one side, I must. So I'm going to add 5 to this side. Now, when I write these little 5s in, they're smaller. Okay, I want them to be a little bit smaller because that's the operation I'm doing. That's the kind of the work that I'm doing. So this cancels those out. And on the left-hand side, always read from the left to the right. What do I have left on the left-hand side? An x. I have an equal sign, and I have a 9. Okay? That is the work that I need to see. And I know right now you're figuring, oh, that's tedious. But later on, when they get to be very jumbo questions, this is the stuff that's going to make the mistakes. So let's go to the next one. So we always look at the side that has your variable, right? And we decide, how do I get that variable by itself? Right? I have a minus 6 on that side. How do I remove that? So plus 6. What I do to one side, I must do to the other. Cancel those out. I go from my left to my right. X is equal to 13. Left to right. Okay, stop. Stop. I now look at this. All I've done in this question is move the variable to the other side, right? Again, it is important that we write it in proper form, that we are not flipping sides. So my x is on this side. I must remove something from the right-hand side. So I'm going to add 4 so that I can remove this negative 4. But I'm going to do this on the other side. Now, the key thing is not that. It is how I write my answer. 7 is equal to x. Left-hand side equals the right-hand side. Do not flip your question to x equals 7. You're flipping the whole question around, right? X is not on the left, on the right-hand side. It is on the left-hand side, right? Or on the left-hand side, right side, not the left. Okay? It's not here. I do not want to see this. That is not the correct answer. X equals 7 equals x. Okay? And the reason for that is if you start flipping sides now, when the questions get bigger and you start flipping things, that you're going to get them wrong. Okay? So I'm going to be picky about that right now. And I know that x7 equals x or x equals 7 is exactly the same thing. It is exactly the same thing. But I need you to think left to right, not just write down an answer. Okay? So again, my x is on the right-hand side. I need to remove this. This is a negative 7, so I'm going to add 7 to it. What I do to one side, I have to do to the other side. Cancel those out. Again, I'm working from left to right. 10 plus 7 gives me 17 equals my x. All right? So I'm going to, so those are all subtraction. So the next row is all addition. And it really, all it is the different combinations. I have x plus 5 equals 4. X is the side I'm looking at. I'm working with that. How do I remove a positive 5? Subtract a 5. Again, write those in. They must be written in. Okay? So I go left to right now. X equals 4 minus 5, giving me a negative 1. Now x is in the second position on that left-hand side. Doesn't change what it is. I need to still get rid of the 6, subtract off the 6. What I do to one side, I must do to the other. I go left to right now. X equals 4. X is now on the right-hand side. So I deal with only the right-hand side. This tells me I'm going to subtract 5 from both sides.
It's not that easy. It's just not.
7 minus 5 gives me a 2 equals an x. You're always dealing with the side that the x is on, right? Because I could remove the 13 or I could remove the 4. But which one is it that I need to remove? The 4. Because if I remove the 13, don't write this. If I remove the 13, then I end up with everything on this side. Does that help me get x by itself? No. So you always work with the side that has the x. So I'm going to subtract 4, not the 13. Again, left to right. 13 minus 4 gives me a 9 equaling an x, not an x equaling 9. All right? So that's adding and subtracting. No problems there? Multiplication and division. Multiplication and division, as I stated before, we do not use time signs because a lot of times I use an x. We're going to use brackets to use multiplication, not anything else but brackets. And we're going to use the fraction like a dividing symbol as a fraction thing. So I have, this is 3 times an x, right? 3 is being multiplied to an x. It's equaling a 12. How do I undo multiplication? Divide. So this is what you're going to do. You're not going to use the little dividing symbol like that. That is not what I want. The reason for that is it's messy. Divide each side by 3.
Why?
So that I can cancel those out.
And get a 4.
And I get x to equal 4.
Oh my god, I did that before. I'm so smart.
Okay? So division has to be represented by the line. So again, I have a -8 multiplied to an x equaling a 64. I work with this side that has the x. I have multiplication. This is not a division or a subtraction, right? We don't add 8 to get rid of it. We divide. And again, it's a -8. I want to remove the 8 and the negative. So I'm going to divide by the -8.
So then you get 8.
I'm going to cancel that. I'm going to get -8.
That's what I meant to say.
Good.
I did say that actually.
Now, it doesn't really matter which side the x is on. You just work with that. Again, it's 7 times x. Divide by 7. Divide by 7. Cancel those out. Left
7.
to right.
7.
7 is equal to x.
Oh my god.
All right? I work with the x side. I need to remove that -4. I'm going to divide by -4. Again, left to right. -9 equals x. Okay? No problems there? Now division, these ones are divided by. So in order to undo division, what do I have to do? Multiply. So multiplication looks like this. So if I want to undo the 4, I'm going to multiply the numerator by a 4. Because if I multiply the numerator by a 4, then I can cancel them. But when I put it over to the other side, it must look like that.
12.
Okay? And the reason for that is I don't want to put an X symbol in there. I don't want to write just, I don't want to just do this. Because then all of a sudden it looks like a 34.
Yeah.
Right?
4 like 34.
The 4 must be in brackets to
Yeah,
represent
and-
multiplication. Stop.
And then equals 12. See,
X
I know
equals
my-
12.
I know my multiplication.
I'm being picky.
I know my multiplication table.
So again, I need to remove the -5. I'm going to multiply the numerator by a -5 and the numerator of the other side by a -5. I'm going to cancel them out. M is equal to -30. The process is more important than the answer. Again, T is on the right-hand side. How do I remove dividing by 3?
Times by 3.
Times by 3 with a bracket, they cancel out. Times by 3. Now, you can put them in front like that, or you can put it behind your choice. I don't really care.
What if that was a 4? Would it become, like, would that become a positive 20? Or would it still be negative?
This is negative. So positive and a negative gives me a -15, right? Equaling T. The next one is an example of what you're talking about. So again, I have x. I look to the side that has my variable. I am dividing by a -4. How do I remove dividing a -4?
Another negative.
Times by another -4. Numerator always goes in the numerator. It does not go down here. All right? That is not where we put it. It must go in the numerator because something in the numerator will cancel with something in the denominator. What I do to one side, I do to the other side. I get a positive 32 equaling x.
I just got off.
Can you guys shut up?
Okay?
Like, actually, shut up. You guys do stop talking how many times.